So we're going to continue looking at domain and range. So remember, the domain are all the x values that are part of the relation. They are the independent variables. If you're looking at a graph, it's what goes left and right. Because on a graph, normally the x-axis is the horizontal, where the range is the y-axis. Okay? They are the dependent variables. In a table of values, the range comes from the second set of numbers in a table of values or in a set of ordered pair. And on a graph, you're asking, does the graph go up and down, and how far? We've looked at two different types of data, continuous and discrete. With discrete data, you're just looking at individual points. There's no lines or curves connecting them. So you're just looking at those individual points. But with continuous data, the points are connected with a curve or a line, which is what number 1 shows us. That is continuous data because it is a line. But this line has a definite starting point. This line starts at the point 2, 1. So it's from those two numbers that we'll get our domain. So we can state the domain of this. Whenever you have continuous data, you can use interval notation. Remember, with interval notation, you always go from smallest to greatest, and you have to make sure that you have the right shape of bracket. So the minimum x value here is positive 2, which is included. And it's going to go upwards and to the right forever, which means it's going to go up to positive infinity. So using interval notation, that would be the domain. We could also use set notation. All values of x such that we would just have to say x is greater than or equal to positive 2. And x belongs to the element of real numbers. So that would be the domain of that relation. The range, well, that talks about the y values. It asks, does the graph go up and down, and how far? So this graph has a minimum value of positive 1. That's the y value. And then it goes upwards from there. As it goes to the right, it's also going upwards forever. So the range would go from 1 up to positive infinity. Again, the 1 would be included. The infinity is never. If you wanted to use set notation for this, you have to remember that the variable is the letter y. You would say all values of y such that y is greater than or equal to 1. And again, y is an element of real numbers. So there's the domain and range for that one. The second one, as we said, that is discrete data. So the only option we have for this is to state the domain and the range as a list. So for the domain, it's the x values. This point has an x value of 1. We've got 3 points with the same x value of 2, and then the last one has an x value of 4. So there's the domain. You cannot use set notation for this one because they are not consecutive integers. Same thing with the range. Our only option is a list. We have the first y value of 1. We have 2 points that have a y value of 2. Then there's a y value of 3. And the last one is a y value of 5. Because they are not consecutive integers, again, you cannot use set notation. Remember that you can never use interval notation if we have discrete data. When you use interval notation, you're saying it's real numbers, meaning all fractions, all decimals, as well as all integers are part of that relation that fit your restriction. In the case of the first one for graph 1, the restriction was that x had to be greater than or equal to positive 2. The fact that that's real numbers because it's continuous data means it's all fractions and decimals, as well as integers greater than or equal to positive 2. Okay, so this next graph, you can see you've got arrows at the top there, which means it's going to continue in that pattern forever. As it goes up, it's going to continue to spread out. which means it's going to go to the left and right forever. So our domain, if we use interval notation, would be from negative infinity to positive infinity. And we need round brackets on those because the n values are not included. Or if we use set notation, all values of x such that x is an element of real numbers. Again, that means it goes left and right forever. Our range is different though because this graph has a minimum point right there. The y value at that point is at negative 3. So the range goes from negative 3 up to positive infinity. And the negative 3 is included, so we have the square brackets. Infinity is not. If we use set notation, we would say all values of y such that y is greater than or equal to negative 3. And again, it's all real numbers greater than or equal to negative 3. Graph number 4 is an ellipse. This graph starts at negative 3 and goes to the right as far as positive 3. So remember, the domain is asking, does it go left and right and how far? So this goes as far left as negative 3, as far right as positive 3. So because those values are both included, we use the square brackets. And we can also use set notation. All values of x such that x is greater than or equal to negative 3, less than or equal to positive 3. And again, that is continuous data because all the points are joined together with a curve. So that means you're dealing with the set of real numbers. The range is different. It has a minimum value. Actually, the range isn't different. It's just a scale that's different. It starts at a low point of negative 3 and goes up to a high point of positive 3. And when you write it in set notation, the only thing different is the letter y is used. Okay, so those are the options that you would use for the domain and range. You could also say them in words. The domain for that last one in words would be all real numbers between negative 3 and positive 3 inclusive. Number 5. So you got a graph of a triangle there, but it doesn't change the way we get our domain and range. For our domain, we want to know how far to the left the graph goes. So the furthest point on the left is negative 3, and the furthest point on the right is positive 3. Same as the last example. So set notation would look the same as well. And the range, this one goes down to a minimum value of negative 2, which is included, a maximum value of positive 4, which is also included. So we use the square brackets. And remember, with set notation, when you're talking about range, the variable is normally the letter y. Number 6, notice the open dot on the starting point, which means that that point is not included. So write down what you think the domain and range of that is, and then we'll check it. Open dot at the starting point, remember, means that point is not included. Sal, what would you say the domain is? Like that? You agree with that, Sophia? Sure. And if you're going to use set notation because it's continuous data, we would say all values of x such that x is only greater than -3, not equal to. And again, it's all real numbers greater than -3. Emery, what do you think the range is? Can you help her, Allie? Say again. You want to bet a pop on that? You don't know. Would you bet a pop on that, Jan? Why not? Because what? Well, what do you think is wrong? It's a positive one. Yes, we're starting at a positive one, not a negative one. So our range in set notation, we would say that y is greater than +1. And it's all real numbers greater than +1. All fractions, all decimals, all integers greater than 1. But the 1 is not included. So let's talk about a graph with a restricted domain. A variety of corn plant grows at an average rate of 4.5 centimeters per day from the start of the 3rd week of growth to the end of the 6th week. The plant's growth can be modeled using that formula, h equals 4.5a plus 25, where h is the height of the plant in centimeters, a is the age of the plant in days. It says use a graphing calculator to create a graph of a corn stalk's height from the beginning of week 3 to the end of week 6. So we'll see how this works on the graphing calculator. But first, we can do a table of values for this. Right? The independent variable, remember, is the one you always start with in a table. And it is the variable that's inside the equation. So that would be the age. That's A. You see, the height of the plant will depend on how long it's been growing. The height of the plant will depend on the age. So the height depends on age. That makes A the age, the independent variable, and that is in days. And we'll get H, the height, and that is in centimeters. So we are going to start this table. So let's draw a box around here. And we'll start this table at time 0. Which would correspond to the start of the 3rd week. Because we're told that it grows an average of 4.5 centimeters per day from the start of the 3rd week of growth to the end of the 6th week. So 0 would be the start of the 1st week, and then at 7 days you'll be at the end of the 1st week. And then 14, I said 1st week, I meant 3rd week. So 14 would be at the end of the 4th week. Another week Now, the 21 days would be the end of the 5th week, and we need to go all the way up to the end of week 6, so we'll have to have 28 days there. And we can extend this. And we can plug those different values of a into the equation. When a is 0, 4.5 times a is, times 0 I should say, is 0, but then you're going to add 25. So this is the height of the plant at the start of the 3rd week. And then after 7 days, which will be the end of that 3rd week, we're going to let a equal 7. Now most calculators will do order of operations for you, which in this case you'd have to multiply first before you add the 25. But that gives us a height of 56.5 centimeters. And then after 14 days, now a is 14, so it's 4.5 times 14 plus 25. Gives us a height of 88 centimeters. After 21 days, it's 119.5 centimeters. And then finally, after 28 days, 151 centimeters. So we're talking about the fact that we have a restricted domain here, meaning that you cannot have any negative values, right? Because you can't go backwards in time when you're talking about the growth of a plant. So we can look and see what this graph looks like in our graphing calculator. So if you have a graphing calculator, you want to turn it on. And the very first button at the very top where it says y equals, you want to click that. And this is where you put your equations in. Now, I had a couple of equations in there from this morning, so I cleared those out. And now we're going to put this equation in there, which is 4.5a, but we only have one option for variable in the calculator, and that's the letter x. So you can see the x key is in the 2nd row, 2nd column. It's just to the right of the alpha key or just below the mode key. It says x, comma t, comma theta, comma n. That's your variable. And the only option we have is the variable x. So there's 4.5x plus 25. Hit enter, and now that equation is in the calculator. If you don't have a graphing calculator, you might look at getting one because it will be quite helpful as we continue to go through this course. Sometimes the library does have some that can be signed out, so that's an option as well. Okay, now if you just hit graph, you may or may not see the graph of it. It all depends on what your windows are set to. So you can see that you actually, on my calculator, you can see the graph, but it's so close to the y-axis that it's really difficult to really get a good picture of what this graph looks like. So because of that, we're going to change our window. So if you hit window, this is where you set your parameters for your x and your y-axis. Now, we have a minimum value for a, which is x in this case, of 0. So right now my calculator is set for negative 360. That's way too small. So even though our minimum value of x is 0, I'm actually going to write it as, let's say, -5. And the reason I'm doing this is that when we hit graph, we will clearly see the y-axis. And we'll talk about that when we look at the graph. Now my table tells me that the maximum value of x I have here corresponds to the maximum value of a, which is 28. So let's go a little bit beyond 28 and say that's 30. So I have a x min of -5 and x max of 30. My next line is for my x scale. So how much does each tick mark on the x-axis count for? I'm going to set that at 5. So every time I see a tick mark along the x-axis, that's going to count for 5 more days. Okay? Now, we need to set our windows for our y values, which correspond to the height of the plant. So according to my table, I have a minimum height of 25 and a maximum height of 151. So I'm going to put my y minimum at -5. Even though you can't have a height that's negative, what this allows us to see when we hit the graph is that we can clearly see the x-axis. The maximum value in my table is 151. I'm going to go a little beyond that and say I'm going to go up to 160. And in this case, I'm going to set my x scale, or my y scale, I should say, at 20. So every tick mark along the y-axis will count for 20 more centimeters. So now when I hit graph, I should see a better picture, and I do. Much better. So there's the graph of that relation. And again, by setting my x minimum at -5, I can clearly see the y-axis. Same thing by setting my y minimum at -10, I think. I can clearly see the x-axis. If you set the minimums at 0, then you'll just kind of see the edge of each axis along your edge of your calculator. So sometimes it's kind of hard to see where the axes are when you do that. Right? So there's our graph. Now we can do a couple things. We can check the points that we have in our table of values by going into the trace mode. When you're in the trace mode, you can manually input any x value you want. The first one being 0. So as soon as you're in trace mode, if I just hit 0, you look and see what happens. It says x equals 0 down below the graph. And when you hit enter, it goes to that point and it tells you what the y value is. Y value at 25. They match. I'm still in the trace mode, so if I want to check the point where I let x equal or a equal 7, I hit 7, and notice that x equals 7 shows up below. When I hit enter, it goes there on the graph. It also tells us our y value, 56.5. They match. If I go to 21, again, there's the right y value, 119.5. They match. And the last one is 28, 151, which matches the value we got on our table. Right? So calculator can be used to graph not only lines but curves as well. And as we move further on into this course, one of the things we're going to be doing is finding the point of intersection between two lines. And your calculator will do that. And it's going to be helpful to have it and know how to do it so you can check your answers. Okay? So we did the graph on the calculator. The same species of corn grows at an average rate of 5 centimeters per day from the start of week 7 until the end of week 9. The plant's growth in this period is modeled using that formula, h equals 5a plus 214, where h is the height of the plant in centimeters, a is the age of the plant in days. Jan, you with us? So in this case, we're going to graph this manually on our page, and then we'll use our calculator to check. All right? So we'll start with a table of values like we did before. Again, the independent variable, the variable that's in the equation is a, which is the age in days again. The dependent variable will be h, the height, which again is in centimeters. And we're going to start at the start of week 7. So times 0 will be the start of week 7. 7 days will be the end of week 7. 14 will be the end of week 8. 21 will be the end of week 9. And we can use the equation and our calculator to determine what the heights are for those numbers of days. First, when a is 0, well, the equation is 5 times a. 5 times 0 is 0, plus 214 will give us 214. When a is 7, we need to go 5 times 7 plus 214. Our height is 249 centimeters. When a is 14, it'll be 5 times 14 plus 214. 284 centimeters tall. And the last one, when a is 21, (319 centimeters). So there's our table, which I'll now draw our boxes around. So we are going to graph this on our calculator, but first, let's see what it looks like if we graph it manually on our page. Remember that the independent variable always comes first, and it is on the x-axis when we draw our graph. So at the bottom here, I'll have a line for my x-axis, which is my a-axis, and another line for my y-axis, which is the height axis. And as I said before, you always need to label your axes. Again, the first thing in our table is the age of the plant. That is the independent variable. It always goes along the bottom. So this is the A, which is the age in days, where the second variable H is the height, and that is in centimeters. So you always need to have your axes labeled. So it might be a little helpful if you had a straight edge for this as well. We also have to choose a suitable scale on both axes. And for my age, I'm going to start at 0 and go up by 7s. So that might be 7 days, 14 days, 21 days, and that's how high this table goes. Our height has to go up to 319. And remember, you need to choose a suitable scale, and so every tick mark has to count for the same number of centimeters. We have to go all the way up to 319. So what I might do is I might say, I'm going to choose a scale of 50 centimeters. So my first tick mark will count for 50 centimeters. Another one will be 100, then 150, then 200, then 250, then 300, and then 350. Sometimes you'll see this happen where you've got the same scale, but they only mark every second value. So they didn't write 50, but then they write 100. They miss 150, but then they write 200. And you got 300, and this last one to be 350. And because of what our scale is, we're going to have to do some estimating. We're going to have to do some estimating of where our points are. Our first point is 0, 214. So at x equals 0, we'll be at 214, which is just above 200. So we'll say approximately there. Our next point is 7, 249. So that's just below 250. 14, 284. So that's just below 300. And 21 comma 319 is just above 300. And this would be continuous data, right? The plant will always be growing continuously. It's only measured every 7 days, but it'll be continually growing. And it's going to grow at a constant rate, which is why those points should line up. Now, again, I kind of estimated where all these points were, so all my points don't line up exactly, but they should. So after we draw our line, we can just make the points bigger if we want, just to show that the line does go through them all. Now, in this situation, the line will actually stop at that point. Even though the plant continues to grow, this experiment, if you want, is only lasting a certain number of days. It's only going till the end of week 9 or for 21 days. So because of that, if we're going to write our domain and range, we will have to keep that in mind. Our domain would only go from 0 to 21 days. And again, this is continuous data because the time is always ticking forward. So because it's continuous data, we can use interval notation. And our range will go from starting at 214 centimeters and go up to 319 centimeters. And again, because the plant is continually growing, that is continuous data. And because of that, we are allowed to use interval notation. Could also use set notation. It would be impossible to use a list, though, because a list is where you state every value, and it's not possible. Because every fraction and decimal between 0 and 21 would be part of this relation. It's impossible to write them all down. And as I said, we could also use our graphing calculator as a check. So I have my equation, y equals 5x plus 214. So my equation is in there. My windows are going to change a little bit. So again, that's up at the top. Right beside the y equals button is your window button. I can start at -5, no problem, but I only need to go up a little past 21 for my maximum, so maybe I'll change that to 25. And a scale of 5 is fine. For my y minimum, I can start at -5. And I need to go up something past 319, so we could go, let's say, up to 350. Whoops. -5 up to 350. And let's put our scale here to 50 instead of 20. So now every tick mark along the y-axis will count for 50 more centimeters. So now when I hit the graph key, there's my line. And it looks, fairly similar to the one that we have drawn. If we go into our trace mode, we can check some points. For example, when x is 0 or a is 0, it starts at 214. That's the right point. When a is 7, I get 249. That's the right value. When a is 14, 284 is correct. And when a is 21, 319 is correct. So the graphing calculator can be used to check the numbers in our table and also to make sure that our graph looks correct. Okay? So there's another assignment there. The difference here is that you can choose whatever method you want to state the domain and range. In yesterday's, You had to do it in words, you had to do it in interval notation, and other ways as well. In this case, you can choose whatever method you want. But remember, you can only use interval notation if it's continuous data, which is true for all the graphs on page 1, but not all the relations on page 2. Some of them are discrete. The last 2 are discrete. So you cannot use interval notation for those last 2. So again, you need to do this. You're going to hand this one in for marks as well. If you didn't get the one from yesterday done and handed in, you need to do that. They're both due for marks. So if you don't have yesterday's handed in, start working on that today, get that handed in, and then you can work on this one. Yes, both sides. Yes, sir. What's your question? Okay, just hang on one sec. I want to stop this.